You're watching InTechnology, a video cast where you can get smarter about cybersecurity, sustainability, and technology. Here are your hosts, Tom Garrison and Camille Morehart.
Hi, and welcome to the InTechnology podcast. I'm your host, Tom Garrison, and with me, as always, is my co-host, Camille Morehart. And today, we have a very special guest, Matt Adiletta. Matt is Senior Fellow at Intel, focused on the data center of the future. He has experience in embedded software, data analytics, silicon microarchitecture, system design, networking, and ASICs. So a lot of background for Matt there. And he is also the acting CTO for the data center and AI group. So welcome to the podcast, Matt.
Thanks, Tom.
Well, we have worked together many, many years ago. So it's a little bit of a homecoming. So it's great to see you. And we've got a great topic today, and that is data center of the future. Why don't we just start with the basic high-level description of what is the data center of the future? What problems is it trying to solve that's sort of different than the data centers that we have today?
That's a great question, Tom. And I think that's projecting what's going to happen in the future is really a tough thing. But we can see what's happening and what the trends are and how we're going to address them. What I see as the data center of the future is the scale of the data centers have just been tremendous. And as more applications and more work moves to the cloud, that scale is increasing. But it's interesting, if you talk to the CSPs, the key thing that is first and frontmost to them is security. So people will go to the cloud and go to these data centers of the future only if they really feel as though their data and their application, their presence is secure. So the first thing that has to be is that the data center of the future has to be secure. The second thing that I see about the data center of the future is that it has to have a consistency. When you operate on that data center in the future, it has to operate the exact same way every day, every moment that you go to it. So it has to have a consistency of behavior and response to you. And then you have to have this belief that everything that, in addition to being secure, you're private. So people aren't understanding what you're doing, even though you're secure in what you're doing. So there's this inherent privacy, availability, reliability, and then performance. And so now if you look at that from that forward-looking view, how do we do this at scale? And what do we have to do from an Intel perspective, since I'm looking at it from that perspective? What does that data center look like?
So it's thinking beyond, obviously, just the compute part of a server, which is one, it's obviously important, but thinking about networking, storage, the entire system at the high level, and figuring out how to maximize the efficiency out of that.
There's multiple views you have to take of this data center of the future. The first view is, as I was describing, as a customer going into the cloud as an example of that data center. And then the second view is if you're owning the cloud and you're looking at vendors to put into it, what are those value vectors? So their big value vector that they look at is that, okay, I got to be secure, I got to be private, I got to have consistency, I have performance, but my metric of goodness will be how much does it cost me? So I need to have all of those attributes providing at best-in-class cost. And that ends up being something that they reference as the TCO, the total cost of ownership, which includes acquisition costs as well as operational costs. And what you just said before about the storage, the networking, the compute, the accelerators, that all comes as part of that data center in the future. And what's really interesting is that if you look at the evolution of data centers, there was a point in time where the data centers had an Ethernet network for computing and talking amongst themselves, a fiber channel or a storage area network that would operate for storage. And over time, those networks converged, and because of operational costs and expenses and ways to optimize that. And what we see happening again is things like large language models or ChatGPT as an example. What's happening with ChatGPT is that you need to take a bunch of accelerators and interconnect them in a very highly connected fashion in order to perform the function. Where we had multiple networks and different management networks and stuff, we converge to a single network within the data center. We see an emergence now of a need of having this private network that manages data of the AI along with your normal data center network. But what we don't want to do in this data center of the future is have that same problem we had before, where we had two different networks. So you want to have a consistency, a security model, a privacy model, and a data center operational model that provides this capability of difference, but not doing it with different things.
It sounds like AI is driving a lot of these newer needs or newer requirements in the data center. I'm wondering, conversely, are there some kinds of architectures or things that are now possible or in development in the data center that are going to change what's feasible from an AI perspective?
I have to say, Camille, AI, it's just exploding. And what's really interesting to me is I was talking to one CSP, and the demand that they see for AI is incredible. What are the limits to the AI? And what we see is that if you look at these AI models, they're growing in size and memory footprint. And there's a couple of really interesting, not to get too down in the weeds here, but if you look at Moore's Law, we continue to show ability to add more cores. DRAM and memory is having more of a challenge. They've hit the wall a little earlier, but both of us are hitting a power wall. And that power wall, as you go to these complex large language models, is a substantial problem. And so for CSPs or cloud service providers that are trying to deploy inference and AI capabilities at scale, power is becoming a really big thing. So everyone's looking, how do we deliver these complex algorithms at the most power efficient points? I think there is incredible innovation going on now in that space, and specifically how you do management of the problem as well as memory and what the compute engines look like. So within the data center of the future, I mentioned earlier that the two networks. That little private network over here was actually interconnecting all those accelerators that are performing some of these functions. And whoever does that acceleration in the most power and consistent, secure, reliable fashion, I think will be the winner. And I know that that's where a lot of our focus here now is how do we deliver that capability in a really efficient manner? And what's really interesting, we have a lot of interesting tools technology-wise. If you look at the needs of bandwidth and power and cooling and compute all put into the silicon, this new AI stuff is driving technology development at such a rapid rate. It's really exciting.
So you talked about power. So let's just talk about power a little bit. So my understanding back from the data center days when I was over there, back then we were really focused on the power getting into the data center. So I think our listeners, people that are in the server world probably get this, but people that aren't, this will be news to them. So getting the power into the data center is a huge problem. Just getting enough power. So think about these potentially millions of servers all in one place, getting enough electricity in from whatever sources you have is a huge problem. When it goes through your chips and your chips do whatever it is it's going to do in the data center, it generates heat. And so heat is another form of power, and you've got to get the heat out of the data center. Otherwise, everything burns up and melts and causes all kinds of issues. So can you talk a little bit about the sort of technology in the context of the data center of the future? How are things like cooling technologies, like immersion, for example, how does that play a role? And can you describe what that is? Because I don't think people would even can grasp what does that even look like?
If you look at servers, the servers at one point, when you and I first started working on them, we were like 45 watt, and then they went to 65 watt, and then we hit our heads and we said, oh my God, I'm going to have a 95 watt SKU. And now we're talking 450 watts is something that we'd be selling now. And if you look to the data center of the future, I see some of these accelerators, they want to be close to 1,500 watts. So you got 1,500 watts in this little XY area that needs to be cooled. So what do we do? What we're looking at now is liquid cooling. And there's two different types of liquid cooling that people are looking at. The first is, as you said, Tom, the immersion. And in immersion, you basically take racks today are six feet tall racks with 40, 42 slots for putting servers in. And we would take that rack and turn it on its side. And basically it looks like the old freezer chest with a top on it.
Yeah, like a chest freezer.
Yeah. And what they do is they fill it with a mineral oil and they cool things by taking the rack that was top and putting it in and then just putting the shelves in the mineral oil. And the mineral oil doesn't affect the electrical nature of anything, but it just has this ability to take the heat and move and pump the fluid. So in an immersion, you can do with that, or you go into this crazy stuff called two-phase, where you put it in a tank, and you have there's these new amazing engineered fluids, which as you heat them, you can set the boil point to them. So you have, just like we had before, a board with a chip on it and the fluid is next to it, but you set the boil point such that it boils at the heat that you want to keep the chip at. And what's amazing is that when you have that bubble form and the bubble move off the surface, it takes the heat with it. It effectively breaks the laminar flow, takes it away. So what in two-phase, you get a surface that you try and get a boiling enhancement coating on it that gets these little bubbles, and the little bubbles are all bubbling off, and that bubbling takes all the heat away. And then the bubbles come up, and then you recover in the vapor that fluid, and it comes back and you recycle it. So you kind of have this loop of evaporation or bubble, boil, and then condense to bring back fluid in this two-state. And from this, you can get to very, very high levels with these engineered fluids. But the engineered fluids are very expensive. So now the question is, what's the best way to get this temperature out? We can make the tanks that look like freezers on the side. You can make these tanks that you boil things off, or you can do cold plates. And right now there's a big push on cold plates. And what cold plates do is you servers are typically flat. You put the cold plate on top and you run a fluid through the cold plate. And you can have either a single phase where you're running a very clean water through it, and you're floating it the cool water fast enough that you take the heat away, or you do a two-phase where you bubble inside and then the vapor escapes, and then you recover it and you bring more fluid in. So you kind of have this two-phase. And what's happening is everyone's moving towards one of those three cooling systems because of the heat that's happening. But this cold plate stuff, that gets much closer to how the silicon has to operate.
We're talking about hardware architecture, and I want to ask about software architecture also. Could you just spend a minute talking to us about some of the kind of emerging trends in helping to deliver software efficiently?
In the software space, what's happening is we are going from these programs that were linear, procedural on one machine to the data center in the future, which is actually today, which is an application where part of it's running on this machine, but most of it is running on a bevy of other machines, and those guys are reporting back. And so now when you change your mental model of optimization of a data center of the future from this monolithic program that runs on this machine to instead a small piece here and lots here, all reporting back, you now have a different view of what do you have to value in the processing here, as well as what do you value on the network. That delineation becomes really interesting when you bring it back to the security thing and that privacy thing I was talking about. So you can see one of the things that I'm trying to, or that we're trying to do, that, and the CSPs are doing a great job at this right now, is disaggregate the infrastructure of running the cloud from the processor that runs the application. And so what has happened is, it used to be that you'd have a processor, and as we were just talking about this distributed software, you'd have a processor, and then you'd come out to over a network to another machine over here. And that network was Ethernet, or is Ethernet. We come out to that distributed over here. Who manages the packetization of data and information from this application to that worker distributed out here through this network? And so what happens is that there's this little network interface, the Ethernet. So who packetizes it? It used to be that packetization and processing of that communication happened on the processor, the CPU. And in order to manage that communication, the infrastructure owner, the CSP, has to manage that network, which means they have to have some control over that network packetization and security and mechanisms there, which means that the infrastructure provider is actually sitting on the processor that you're going to run your application on. And in order to really deliver that level of security and privacy that we were talking about earlier, what we really want to do is take that infrastructure's software off of the application processor and move it into an infrastructure processor. Hence, what we've introduced on the data center of the future is this IPU, the infrastructure processor unit. And what it's doing is it's taking the software that the CSP or the service provider is using in order to manage and deliver the data center capability to users, and taking it off the application processor and putting it in a processor in front of it that is in between here and that distributed node. And on that other side of the distributed node, there's another IPU that's sitting there before it goes to the worker. So now we have this disaggregation of the infrastructure and the network coming back here, which means software has to change. Software has got this distributed mechanism to it. And now you have to synchronize. I want to do these 5 things. And you go out to ask 5 people. Well, you can't go on until all 5 guys come back to you. So there's this exchange capability. And now if you're designing the processor over here, you now have to have a different set of optimizations to that processor than if you had a monolithic program just operating here. So now you have to manage interrupts and control structures and moving data remotely and receiving data remotely in a much more efficient manner, because now it's all about data movement and interactions with others.
Obviously, there's a lot there. The amount of change there is crazy to actually wrap your head around. But we're almost out of time. I always think it's good when you get somebody like you who's got their hands in all these details to just say, what do you see in the future that really excites you in the context of either things like what artificial intelligence will be able to deliver, what the data center of the future is going to do? What really excites you about the future?
Often from youth that you get the most learnings. I have a son, and I sat with him the other day. He paid the $20 to get ChatGPT 4. We asked ChatGPT for a question. It asked us a question back, which was really interesting. And the next thing you know, we asked, how would you like to see that data? And it said, run this. And it produced some code that we ran on his PC that would generate a log file. We generated the log file, copied the log file back into ChatGPT because it wanted to see the log file, got the log file back, and then it said, here's the code you should run, and gave it new code, took the code, put it in, and the bug he was having went away. It seems to me that we are on the verge of being able to understand things that only our imagination is going to keep us from extending to.
It's a great topic, and you're a great guest explaining all this stuff at different levels. So thank you, and I look forward to hopefully all the things you talked about coming true.
Never miss an episode of InTechnology by following us here on YouTube or wherever you get your audio podcasts.
The views and opinions expressed are those of the guests and author and do not necessarily reflect the official policy or position of Intel Corporation.